passion since it's many years everything around the smart home and home automation. And I would like to present today from the perspective of an end user, more or less, that wants to buy gadgets for the Internet of Things and how the things are presented towards him, and where the problems actually are. And to give you an idea of the problems that I want to speak about is, I want to just go to some Christmas shopping together with you and see what's there on the market as nice gadgets that you can buy and which are internet-enabled devices and what you can do with that. So, yeah, okay. So let's start with some smart plug. You probably know this one from Belkin Demo. So just plug it into your socket at home, plug in your flat iron or whatever device you like, and from everywhere where you are on the world, you can use the smartphone app to turn it on and off. So pretty neat thing. Another thing, Philips Hue, our new kind of lighting system, which is Zigbee, so radio controlled, or LED bulbs that you can simply replace your existing light bulbs with these nice LED ones. You can not only switch them, you can dim them, choose the color, and so on. Very nice thing. Home security solution, also DEC-QLE, a new kind of protocol, wireless or easy to retrofit in your home with motion detection, siren, door sensors, and all that kind of stuff, so that you can always check on your smartphone app if everything's fine at home. To really see if everything's fine at home, you of course also need a webcam that has a cloud service with it and the smartphone app where you can access it and always look at home what's going on there. While you're at home to do your music streaming and so on, Apple TV is a pretty nice device to do all of that. Okay, also controllable through a smartphone app. Having multi-room systems, surround solution, and so on, you can have Sonos devices that you can control through a smartphone app for your volume setting, whatever. As it's winter time, these are radio-controlled radiator valves that you can program through a smartphone app, and you can do really individual per room. Your heating control. For the central heating, you all know something like the smart Nest thermostat that you can have with another smartphone app. Even your plants, you can put a sensor into it that measures the humidity and the air temperature around it to give you hints when you need to water it again. Very cool with your smartphone app. Having outside and indoor weather and all kinds of sensor data, you can have another weather station here that is completely internet enabled, and you can have all the values on a smartphone app available. Of course, you don't have a TV today at home, you always have a smart TV that is also controllable, switchable through a smartphone app. Even your washing machine can buy connected ones where you can anytime check on your smartphone app how long it will take until your washing is done. There are other smart plugs that can measure also the energy and report that, or if you want to monitor any of your appliances at home. Even if you step on the scales in the morning, your current weight is directly sent out to cloud service, and if you want it or not. And you can look at your nice situation towards Christmas on smartphone app. Probably getting even worse after Christmas, right? There are other smart plugs which have a nicer design, a different kind of protocol, and of course there's a separate smartphone app to control them. And okay, if you're very lucky, you also buy one of these with a nice REST API so that you can control the loading conditions and your batteries on your car through a smartphone app as well. So all pretty new devices, things you can buy, which are working well, but there is really a big problem for the end user now, because we have bought 16 of such systems or devices, and we have 16 different apps, and the user itself now becomes more or less the integration point between all of the stuff. So if he gets a notification from the plant sensor that the plant is dry, he might then activate a smart plug with a water pump to actually water the plant, right? If he gets a notification from his window contact of the home security solution, okay, he can go to his webcam and see, okay, what's going on there. It would be much smarter if the solution would automatically detect, okay, there is some intruder, and directly take a picture of the webcam, send it to you, put it on Dropbox or whatever. But you have to be in that way now here the integration point. And all of this is not really then a smart solution, right? It's you who has to be smart, because you are doing then all the negotiation between your own devices. And additionally, it has nothing to do with automation, because the things are really siloed, only exist on their own, and you become the main integrator and automator of your system. And so I used to call these solutions that are siloed more or less nice end-to-end machine-to-machine solutions, because they are built by some vendor, it's all tested and working nicely on its own, but you don't really reach kind of what people now tend to call the Internet of Things, where things are connected with each other from different systems, different vendors, and so on. So if we don't have a smart home, we don't have home automation by that, is all that is left the home sweet home? Not even that, if you look at it. So what do the devices actually do? All of them, that's quite a normal pattern, have their own cloud service where they connect to. They usually send all the data there and listen for commands from the cloud service. And the smartphone apps then usually connect through this cloud service to the devices. So all of these different 16 systems here, they connect somewhere out to the internet. So we don't really have one cloud where the stuff connects to, but it's really many, many small clouds. And the data is then also scattered between all these different things. So it's not even that you have all your data in one place, that you could do some intelligent things on that. It's really not helpful to have that completely distributed. Furthermore, what happens if one of these clouds goes away? So the device that connects to it is directly unusable then, because it relies on this cloud service being available. If it's gone because the vendor just went out of business or whatever happened, then the expensive device that you bought for yourself is unusable. And that's really a bad situation for the end customer. Another problem with this approach on the setup is that every single device more or less creates a security hole, because it opens more or less one channel through your own personal firewall at home, and many of those devices are based on some embedded Linux system that might not receive any firmware updates and so on. And we've seen in the past months already many press notes where there are devices in the home that have security holes and that are usually not easy to fix. So, for example, here the Violent heating system, the recommendation from Violent was, okay, plug the Ethernet cable from your heating system and then you're safe again. So it really makes a big problem there. So what you also have for your home, although you think that internet always on is set today, if you want to really use that stuff for real home automation, so having a motion detector turning on the light for you wherever you go, then you really rely on that. And having to rely on the internet connection being available and everything fine there is not really the best thing for such use cases. Also, you could think of having a solution somewhere in a cottage where you don't have any internet access or other situations. So actually offline availability of the system is a must from my point of view. So what you more or less have to achieve is that all your devices that you have at home can talk to each other locally. And for this, well, you need some kind of central instance that connects things to each other, which holds your automation logic, where you can configure, okay, what should actually happen between these things, and then could just have one single channel somewhere to have a smartphone app to control your things, to be notified about things, and so on. So having all of that locally is very important, so I tend to call that the intranet of things that you would want to have as an end customer for your things. And you should also then be the one who really owns his own data. It's not directly sent out and you don't have access yourself, but it should be locally available, and you can then decide what of this data you might want to share with your utility provider because they want to do some clever stuff and give you some benefits by that and so on. But it shouldn't be the device vendor who decides what should happen with your data. Now, for this central piece to run on, I hoped actually 1.5 years ago that there would be a perfect device to do exactly that. The Nexus Q, and one or other of you might remember it. Unfortunately, it never came to the market in the end. But yeah, at that time I thought, okay, that's exactly the thing where I would want to run now the software stack on and to connect to these different systems. So as that's not available, the usual situation now, solution is just to take a Raspberry Pi, which is a nice usable home gateway for that use case with enough power, and that's where I started, or where I implemented things then. Now, Eclipse Smarthome itself has evolved from a project that I started 5 years ago, the Open Home Automation Bus, which is actually a solution to do exactly that. So a central piece that you can run on a Raspberry Pi that connects the things, that does automation rules on top, that does data persistence and whatever. It's all based on pure Java and using OSGI for modularity. And this is more or less a solution now for tech-savvy people, I would say. So it's an open source project, people can download it. We have more than 50 different systems that can be connected to and integrated with each other. And yeah, it's a pure software solution. From that, the Eclipse Smarthome is actually the core framework, the core APIs and services, but not the connection to the other systems. So the idea of Eclipse Smarthome is to really have a collaboration project here for the industry to say, well, okay, we have actually these services, these APIs, interesting things for developers to base on, and openHAB would then be just one open source solution that uses Eclipse Smarthome as a basis framework, while other possibly commercial solutions and so on could also take Eclipse Smarthome, take the APIs, and offer services and solutions based on that. Now, what exactly is in there? First of all, there is a quite simple, straightforward domain model for the Smarthome, which is simple in a way that it just describes more or less different kind of data or actors that you have there. So a simple switch, which could be on or off, or you could ask it to be on or off. Things like numbers, where it doesn't define what exactly it is, if it's a temperature value inside the fridge or whatever, so that's not of interest here. It's really just pure raw data that can then be exchanged. The exchange happens through events on asynchronous event bus. So for all your things that you model in your system, you then just send around status updates or commands to these so-called items. Then the services around all of that are manifold, so more or less 4 different categories. First is everything around connectivity. So if you modeled what you want to control, you want to, of course, connect that to one of your existing systems. These are the so-called bindings here in the concept that more or less translate your events to a specific connected system. There's a uniform REST API to access the whole stuff in a common way for user interfaces and so on to use, and also for integration with other systems of Eclipse Smarthome is seen as more or less one system to connect to. The whole automation aspect where you can define triggers, actions, what should happen, and then dynamically put these things together into rules to decide what should happen. User interfaces, there's a declarative approach where you can simply describe what you want to see in the user interface, what kind of information with what kind of UI information like icons, labels, label text and so on. And the rendering and how it's all presented to the user is then up to certain UI implementation. So we have at the moment in openHAB 4 different user interfaces, native applications for Android, iOS, 2 different web applications, but they all are based on the same description more or less, which the user only needs to set up once and can then use across all the different UIs. Then last but not least, persistent services. So that simply says that the volatile events can be in a configured way persisted through different kind of services. It's also an open API, and we have things there like standard simple logging, different kind of database support, or also persistence towards IoT services like XID or similar things. Okay, as I said, one of the core concepts is the event bus. You send the events around there. As services on top of that, we have the so-called item registry, which more or less keeps track of always the latest state for each of your modeled items. And that can then be used by the rules directly because they have to react on a certain condition, and also by the user interfaces which want to display the current state of things. REST API and persistent service and so on also integrate with that. Now all of this is really just a modeled world. You define what kind of things you want to deal with, what should happen in your automation rules, what should be displayed in the user interfaces. This is completely abstracted from any real devices or physical systems. And this physical connection is then really done in so-called bindings that are really OSGI bundles, simple ones that translate then the events to their specific system. And this is quite a modular approach, and we see a lot of community contributions for these bindings, because it's pretty easy to add a new one, then to implement the according code for that, to support yet another system and integrate that. Okay, just an example of the different user interfaces. So the rendering is done in the look and feel of the operating system, while the content and what you get there is then the same. Besides the temperature is a different one because it's a different switch. Okay. Just as a brief overview, these are the different systems, protocols that are supported by openHAB, so where bindings exist for that. You find there usual things here for the US like Z-Wave, Insteon support, for European market rather, KNX, Homematic, and different things. Also more devices like Epson projector, for example, all kinds of different TVs that are controllable, and so on. So pretty large number, and at the moment we have a rate of about one new kind of binding per week. So quite a developments happening there. Okay, let me show you something live now. I brought a few gadgets here with me, and one of them is this nice lamp here, which is compatible to the Philips Hue stuff. So it's Zigbee based, radio controlled, and it comes with an IP gateway that does the translation from Zigbee radio to IP traffic, which I've connected here. With this thing, you also get then nice remote control. You can turn it on and off here. You can, with this circle, change the color. Okay, so pretty nice, but yeah, usually if you're at home, you put that remote control somewhere on a shelf and you won't find it the next day, and it's not really very practical in the end. And especially if you don't think of this thing just doing some color at the side of the room, but you want to replace your normal lighting system in the room, then you also wouldn't want to use a remote control every time you enter the room. You wouldn't want to use a smartphone app every time that you want to switch your light. So on its own, it's really, yeah, it's a nice solution to show off, but it's nothing really practical in the end for your home. So what I would want to do is that I can actually switch this light with some physical wall switch, okay? And for this I brought here some other technology. It's called an ocean. It's also a radio version, and yeah, you can simply switch here. It makes a lot of sound, and that's also the trick about it, because you don't need any power cables to it, you don't need any batteries that needs to be replaced every month or so, but just by pressing here, that's enough energy to send the radio telegrams from this device. So pretty cool thing. And yeah, for the demo, I would now just like to connect these things together. So what I start with is defining an item that is now more or less my light. So I said this thing is a color item, color support, and I call it light. Here, when we open the web browser, okay, we directly get user interface and see we have the light here. Turn it on and off, it works here nicely. It doesn't work here because we haven't connected the lamp yet. So what we have to do is to configure the U binding in this case. So we say the U binding. We have to provide a configuration string, which in this case simply is the number of the bulb that is paired with this IP gateway of U, and this is simply the first one. So we have that here, and if we now say turn on, it turns on. Okay. On off, we have a color picker to change the color of it. Okay, works nicely. So far, we more or less just mimicked the Philips Hue app that exists for smartphones. So we didn't win that much yet. Now, there's a second part, and this I can't remember that well, so I'll copy it from here. We configure the ocean binding next to it, which yeah, just consists out of the unique ID of the device. As I have two rockers on here, I just have to define now which one I want to map to this item. And the EP is an ocean profile, which says how this device actually behaves, so how to interpret the commands from that. And let's try. Right, so we can switch our light now with a physical button. We can also, if we press long, we can dim it, lower. Okay, so that's now really something usable as a replacement for your it's going across two different radio protocols that are now directly interacting nicely with each other and without any visible latency. So it's immediately working. Okay, just to give you an example about a rule that you could do now here. We will move the browser. So for the rules, there is a domain-specific language available that is directly optimized that you can work with your items and the available commands in here. And it's very much Java-like with some additional features on top to make a nice, concise syntax. But also, as we're running out of time otherwise, I prepared one rule here, which should now simply simulate a staircase light. So you want to just turn it on and it should go off by itself after a while, right? If you're somewhere on your stairs and you say, well, this time I'm staying longer, you want to be able to re-trigger it, so it should stay on for another while. So we just say if we receive a command for our light here, and if it's an on, then here it complains that it doesn't know the timer, so we declare a variable of type timer with that name, and the syntax goes away, errors. So we say if we don't have any timer yet set up, we can just create a timer now in a few seconds and have a closure now internally here to say, well, this piece of code should be executed at that time. So that's something that in Java you would usually have to write some init classes and a lot of more code. That's one example where you have a very concise and small syntax available here. So we say turn it off again. If we already had a timer, we just want to reschedule it for a bit later. Okay, and if we have received a different command than on, we just want, if a timer exists, that's also something not available in Java, then please cancel the timer. So if you manually turn your light off, then it shouldn't try to turn it off later on. Otherwise, so the use case is pretty simple to describe in words, but it's quite difficult to really implement it. And if you think now, okay, you might want to have a mouse drag and drop editor for rules, it would be pretty hard to achieve such a logic already. So in my point of view, having really a kind of scripting really helps you in realizing the use cases that you want to achieve in the end. Now let's have a try. I turn it on. And 1, 2, 3, 4, 5. It goes off again. Okay, and we turn it on, and now it should stay on for a while. And then after 5 seconds, after the last on, it doesn't turn off. Is there a bug in my rule? Okay, nobody see it, so I didn't press here, it's off again.
I think it's some of them.
It's what?
It did a summation.
Okay, so what is the time? I don't have that much time left, but I have many other nice use cases to show.
Can I ask a quick question?
Sure.
So you had your domain model, the circle with all the concentric circles and so forth. And in the graphic, it was very focused on the home. So wearables, Internet of Things is much bigger than that. So how do you expand that circle to comprehend those other domains?
Yeah.
Or have you thought about that yet? It just seems like that's the next logical.
It is the project is for the smart home. So in general, I don't want to expand it to more or less the whole world of Internet of Things. So it should stay a bit focused, but nonetheless, as I said, it's not too specific in the way that it doesn't describe now concrete devices like, okay, this is a fridge or a washing machine and whatever, but it really just describes functionalities in a way that you say you have something that is switchable, you have something that could go up or down, you have something that is just a percentage value between 0 and 100, and you can set it to some value, you can increase and decrease it, and that's it. So it's really primitive types inside this model, so that it's usually pretty easy to also support new kind of devices that nobody thought of before.
So if I'm a manufacturer that has a new device with some kind of transporter function or whatever, since this is open source, I should be able to go in, add my own functionality, and ship that binding with my appliance.
That should be possible, yeah. And if you just have to define your appliance then to strip it down to its functionalities, and for each of them you would then provide the recording configuration for different kinds of item types.
Have you seen the app on Android called Tasker? There's an automation app on Android called Tasker.
Tasker, yeah, I know it.
So that's it has all kinds of little connectors and events and rule-based things that you can do.
Yeah.
It's
Actually, there are many people already using Tasker as well together with openHAB.
Yeah.
They then just do an HTTP request to the REST API and so on, and integrate things with each other.
Yeah, that's it.
I'll wait for that.
Okay. First, let me show you some more cool demos, and then we can go to the questions. Let me see if that now works. I actually brought my webcam here with me. And my phone. So this is here. Can you see it? Yeah. This is the Android application of the thing. So we also have a color chooser here, where we can nicely choose the color, and you see it directly works. But now a different kind of how you can actually switch your bulb. We just press long here. We say we want to write an NFC tag with the, not with the current color. I just use toggle now, and I brought an NFC tag here. So I just program that. Did it. Successfully programmed, and if I now don't even have to be in the app, if I hold my phone next to the NFC tag, I can simply switch my light on and off. So, because people usually at the end ask me how much is that, I say, well, about $70, and they say, okay, bit too much. So I say, well, just buy some NFC tags for $1 each, and you have pretty nice switches that you can even put somewhere on the outside, and only you with your phone are able to control it and use it. So pretty nice for garage doors, for example, for sockets in your garden or whatever. We also have, I need to add some further item here because I want to show you voice control. So a very basic kind of item type string, and I add one voice command one. That's actually a predefined name, and I'm using that now in a rule. If I receive voice command, then I'm simply now defining the hue, which corresponds to the color, and I send a command, the hue with full saturation, full brightness. Okay, so let's try if that works. If we are back here on the phone, we just press voice recognition, yellow, yellow, there we go. Okay, just a few use cases with the phone. Then, last but not least, something I have to show you. I brought this nice little device here, leap motion sensor, gesture sensor, and we can bind that now to our bulb as well by configuring the leap motion binding here. We just say, well, okay, leap motion, you can only bind it to one specific specific item, not two different ones. Just say now here for the slide it should be enabled. And what we can do now, we don't need the physical remote control, we don't need any buttons, we don't need NFC tags. We just pretend, well, here's a button in the air, and we can switch it. Right? And we can not only switch it, we can also dim it, going up and down. And as we've seen here, okay, circling the color we can do. Well, we can do the same with our finger right here. Forward, backward. So you don't need any physical controls at all if you have a gesture sensor. So at the moment that's more or less a nice toy for demos to show that, but I think in future you could also imagine to have at your wall some controller like that, and having more complex devices like color control devices where we don't have any physical sensors at the moment, or where you can nicely say, well, let's change the room color temperature in this room here or so. So you could think of for having gesture controllers in the future in the rooms to do that. Okay, that was it. Now we can come to the questions, and as the time is up, the others are also free to leave then. Please.
Yeah, I'd like to understand